Welcome to Part 5, Fibre Channel Communications. In Parts 2 and 3, when we looked at configuration of the cluster, you have noticed now there is no configuration of a non-IP based network. This is because now in version 7.1, SAN-based fibre channel communications are configured outside of the cluster in AIX or the virtual I/O server. So here I've actually logged into the virtual I/O. I've just switched to the root user. And we're going to have a look at, I'm just going to show you the attributes of one of my fiber channel adapters. Now the key to enable SAN-based communications is to switch this target mode enabled attribute to yes from the default, which is no. And also if you read the CAA manuals, we have to change the fscsi device. We have to enable dynamic trunk to yes and error recovery to fast fail. So that is very simple to do. So if you've already got disks hanging off the adapters, we have to put them into defined state, which we can do recursively with the rmdev command, and then we simply set the target mode enabled to yes, and we can double check that has been done. Yeah, so target mode enabled is true, and then finally enable the dynamic trunk and fast failure recovery. Oh, bit of error there on cut and paste. So, and double check that has been done. Yes, so dynamic trunk is yes, and fast error recovery is set to fast fail. Once we've done that, you rerun config manager. You'd remap the LUNs to the virtual clients, and that is done. Just set up the VLAN 3358, and you just simply do that on the HMC. So just create a virtual adapter on both the virtual I/O server and the clients, and then that is done. While we're just, if we just move that back out of the way, if we just have a look on our cluster node, this is our primary cluster node. Let's have a look at the status of the cluster. So yeah, so we're online. What's really important is now that you become aware of the status of the cluster from AIX point of view, and you've got a couple of commands you can use. ls cluster -i and -m are probably the two most useful flags. What we can do is, if you check to my website and you look on the QHA page, you will also see now a new utility called QCAA, and what that does, it does a nice parse of the LS outputs and displays it in an easy to read format. So we can see there straight at the top, we can see the multicast address, which cluster-aware AIX uses now instead of RSCT topology services, and the cluster repository disk. And then we've got two stanzas for each node, and then we can see if the interfaces are actually up and down from the perspective of CAA. So you notice there that EN0 is up, which is good. SAN-based communications is up again. If SAN-based communications were down for whatever reason, so we hadn't enabled target mode, we hadn't enabled the target mode attribute, then that stanza just doesn't appear, it's missing from the list. And then finally, if you notice that the cluster repository communications, this is over the repository disk, is up, so it's available, but restricted and AIX, well, AIX control just means it's under the control of AIX. Restricted means it isn't used, because it isn't used unless you actually lose the EN0 and the SAN-based communication. So it's a third line defense. I'll just give you an example of why it's so important to check the status of the cluster from the CAA perspective. is back at our data center. We've got some really sophisticated Cisco networking hardware. And one of the things we noticed when we first, when I first started experimenting with 7.1, is that initially from the view of PowerHA and the view of AIX, the network interfaces were up and available. But it was not until I was experimenting with failover that I found things weren't working as expected. When I checked the CAA status, the interface were down. And a little bit of investigation with the networking guys discovered that multicasting on the switch ports were set to disabled, which is certainly from a networking perspective that be preferred behavior. So as soon as we enabled multicasting on the switch ports, CAA came up and everything was fine. So this is why it's important to check the state, and it's doubly important to check and speak to your network administrators as well. Welcome to part 6, Application Monitoring. Application monitoring allows PowerHA to monitor your applications. It's optional, but it's highly recommended. Without it, PowerHA doesn't actually know whether your applications are up or down. In order to ensure that event processing does not hang due to failures in your scripts and to prevent hold-up during event processing, PowerHA has always started the application in the background. There's no wait or error checking, and in multi-tiered environments there's no easy way to ensure that the applications of higher layers have been started. Application monitoring provides for self-healing clusters. You can have multiple application monitors per application controller or application server, up to 128 cluster wide. There are two types of application monitors you configure: process and custom. Process monitors for a set of processes and triggers recovery if a process fails. Custom monitors can be used to verify if the application is actually doing some useful work. For example, a database monitor could periodically send transactions to the database engine, verify the response, and return an exit code. Let's have a look at application monitoring in action.